Our next speaker is J. Paul Reed, who is a senior applied resilience engineer at Netflix. He will share his expertise on the topic of, well, resilience engineering, including techniques for architecting for resilience that can scale without slowing your rocket ships down. J. Paul is a very prolific speaker on resilience engineering, DevOps, and the sociotechnical complexity, managed to get that right, challenges and opportunities facing organizations of all sizes, most recently at Netflix. Take it away.
Thank you. Thank you. All right, let's get started. All right, engineering resilience at speed and scale. So, as I said, my name is Paul Reed. There's really only one important thing on this slide. It's my Twitter handle. Elon hasn't taken over yet, so I'm still on Twitter, as a lot of us are. And so we can continue the conversation there as always. As was mentioned, when Dave actually asked me to give this talk, I was at Netflix. And I recently left Netflix, though. We're still going to talk about a lot of things that we did at Netflix. If you've been watching Netflix's stock, they've been having some troubles lately. And what they say, correlation is not causation. But this is totally true. So Reed, if you're listening, give me a call. Maybe come back and get that stock back up. People like to ask, what did you do at Netflix? And so one of the answers I used to give is, I navigate the organization to observe signals of systemic sociotechnical risk so we can activate our adaptive capacity to address that risk. And somebody said, so you run around the building gossiping with engineers about broken computers. And I was like, I don't know how I feel about that, but you're not wrong. So, topics for today. We're going to talk about the R words. Resilience is one of them. We're going to talk about the stories that we tell each other, and then we're going to talk about this concept of how do we engineer resilience. Now, I promise you, Dave and I did not have a conspiracy. We're going to actually, it's like he prepped you all for this talk, so we're going to continue some of the topics that he brought up. So this is actually, I'm really excited about this. I'll give you your check later at the drinks at the end. So let's start with the R words. I want to do a quick survey. Raise your hand if the software or the service that you're responsible for, your teams are responsible for, if you would describe it as resilient. I see 2 hands. All right, 3 hands. What about, would you describe it as reliable? That's interesting. More hands go for reliable. How about robust? A few hands. Okay, how many people just thought I asked the same thing 3 times? Yeah, some hands go up. All right, so we're going to talk about the difference in those words and get some common definitions because that's important. So resilience engineering, where does this come from? It comes from the field of the safety sciences, which started about 100 years ago in the 1920s. And it really came up as a concept actually in the late 70s and early 80s. Some of the events happening at that time, 3 Mile Island, Chernobyl, Challenger. And so resilience engineering is just starting to get into the field of software, and it's super interesting. But they've been around for years in aviation, healthcare, energy, topics such as like that. Nuclear is one of the more interesting ones, I think. So let's talk about all these R words and what do they actually mean. We're going to talk about all of these, and I'm going to start with my least favorite on resiliency. If you Google resiliency, it will say, did you mean resilience? And so I was looking up more about this word, and it's primarily apparently used in academic context. So I personally don't like it. We don't talk about resiliency engineering. I use resilience. So we can scratch that one off the list. Now I want to talk about these concepts using the analogy of a traffic intersection to have us get an idea of what we mean by those things. And I'll give some examples in software systems that we do and manage and develop as well. So let's tackle robustness first. So I always have to read this definition because it is a very academic one. A system is said to be robust if system X has property Y that is robust in sense Z to perturbation W. What does that mean? What it means is that in an example of a traffic light, incandescent light or LED light bulbs are more robust than incandescent light bulbs, because if one of those little lights goes out in a LED light bulb, the light doesn't break, as opposed to an incandescent bulb where if the bulb goes out, the bulb is not available anymore. LEDs last longer, they use less energy. So for certain things, the point here is for certain things that we've modeled, the LED lights are much more robust than an incandescent light. In software, languages that have memory safety guarantees like Java or Rust might be examples instead of C or C++, but they're robust in those specific ways that we've modeled memory safety. So the key point is that the disturbances are really well modeled, and we're solving a specific problem that's going to be with a system that we know is going to be poked and disturbed in a certain sort of way. All right, reliability. So these definition here is patterns that support consistent operations or service levels. So example here is this light pole is reliable in that there are multiple lights, so if one does happen to fail, we can still see who can go through the intersection. It's interesting to note that there's a bit of complexity here because those lights have to be synced up in a meaningful way for it to be useful, so we incur a little bit of complexity to get that reliability. So when we think about in computers, multi-cloud, which we were talking about earlier, multi-region cloud is an example of that. If you've ever had multi-platform software, you might have seen like if you have a Linux and a Windows version of a product, there's a bug that is in cross-platform code that causes Linux to crash, whereas it doesn't crash on Windows. That's an example of different reliability, right? But the key point here is the disturbances are well modeled, but the properties are patterns, practices, and processes. Oops, let's go back. Rebound. So this is the ability to deal with a crisis situation dependent on the structures that have been developed before chaos arrives. So in the intersection example, if you happen to have a lot of people that you need to move across the intersection, there aren't actually guardrails on the crosswalk, right? People can ebb and flow as necessary. We often see this where if there's lots of traffic, people might turn left in front of traffic. What was it called? Like there's a Boston left turn or something like that. That's just accepted people kind of do that. So it's an example of where these systems can expand with differing requirements that are placed on them. In software, a CI/CD pipeline might be an example of that, because if you have to deal with something like the Log4j exploit and you need to roll the entire fleet with new software, if you have that pipeline set up, then you're not going to be doing a lot of manual work. You can just put the changes you need to make in and sort of have a confidence that the stuff's going to come out the end and be deployed the way that you want it to be deployed. But the key point here is it already exists, and it's informed by previous experience. Now the last one, the last R word, and the important one for us today is resilience. So in our intersection example, for the last 45 minutes, this man has kept this New York City intersection alive. This was in a power outage. And this person stood in the middle of traffic, directed people. And this part of this model comes or analogy comes from Alex Ellman, and I like how he said it. Those LEDs that we were talking about is robustness, but resilience was this person doing a thing, keeping that intersection running. So the key point here is resilience isn't something you have, it's something you do. This is why you'll hear a lot of times people in the resilience engineering space talking about sociotechnical systems, because the socio part is the people in the system. What are they doing? How are they interacting with that system? How are they interacting with each other? So now that we've defined some of the things that we need to define around the R words, let's talk about two other things that we need to talk about before we can talk about how we engineer resilience into our systems without slowing down and using the things that we already sort of do. We're going to talk about two concepts here. So first one, storytelling. Some of the stuff that I'm going to talk about is work that Jay Bloom has done. He talks about how can we intentionally address ourselves towards future. So he talks about how would you design if you knew you were going to design a city with a lifespan of 300 years? What would you think about when you were designing that city? So the first component of that is this idea of the time span of discretion. This is kind of hard to see, but the really only relevant part is that you'll see in each of those boxes there's different time spans of discretion, 2 weeks, 3 months, 1.5 years, 3 years. You might ask yourself maybe where you fit in this diagram. And this time span of discretion concept is important because it goes into this idea of telling stories about the future, which is something that we all do. So we all kind of have this idea that as we project forward in time, and this is that model idea that Dave was talking about, There are things that we think are probable. There are things that we think are plausible. There's certainly things that we think are preferable that we would want to have happen. And then there's, of course, things that are possible. Now, one of the points that I want to make is this, our ability to project into the future has a big impact on us. And this is actually one of the elephants in the room about why COVID was so stressful, is because it reduced our ability to make plans in our personal lives and our business lives from quarters or months down to, I don't know where I'm going to get toilet paper next week. And cognitively, that inability to project reasonably into the future is essentially a model breaking down with this component of time. And of course, there's an intentionality here. So I'll give you a really quick non-incident example, because we're going to talk about it a little bit in the context of incidents. If you went into a Starbucks, you have a story in your head about how that's going to go. And you have a story in your head about how all the people in there are going to act. So if the person in front of you said to the barista, "Hi, I'd like a cheeseburger and french fries," and you heard that, you might perk up and go, the story that I think they're supposed to be telling each other didn't happen. And you might go, okay, well, what's next? Now, here's the interesting thing. If the barista pulled up fries and a cheeseburger and said, "Here you go," and the guy walked away, you might even think of that as an incident. You might be like, now what? Am I being pranked? Like, what's going on? So, these stories that we tell are really important. Second concept related to stories. Who's listening to our stories? I'm going to talk about above the line, concept of above the line, below the line. This slide is just that diagram blown up. I want to point out a few things to you. The system, as it exists in reality, objective reality, is below that line. The servers, how they're configured, the networks, all of that. It exists as a factual objective reality. But there's a line called the line of representation, above which, because there's information we don't know, there's obvious complexity in those systems, where we have these mental models of what is below that line. Now, the interesting thing that you might note, users, well, we all have mental models, and you can see those people with the thought bubbles above, but all of those models are slightly different. You're going to have a different model if you're the developer who developed it versus the operator who may operate it versus the database person who came up with the data model. And also, interesting enough, at the bottom, you can see the users. They also have their mental model of how this all works, and it's slightly different. So we're going to come back to this idea because it's important. All right. So how do you engineer resilience into your organization? We're going to talk about 3 different techniques that you can do that. Starting with incidents. So incidents, in effect, are points in time where the stories that we tell each other and the stories that we're telling ourselves about the sociotechnical system in which we're operating are either not true or they are not coherent. What do I mean by that? In this example, we are expecting that our system is operating at some point in time, like in a preferable space. Maybe it's not. Maybe it's actually operating in some place, but it's still probable or plausible. It's not an emergency. But in an incident, it's outside of that space that we expect. It's in a possible space. That's where the system state is. Another way to look at this, in an incident, these things no longer match. And one of the things that makes incidents not only cognitively stressful, but also useful for us to look at as a leverage point for resilience, is that not only is the model different from what's actually in reality, but oftentimes the models that we have with each other about the system that we're trying to work together, that team that is trying to fix that system, those models have broken down not only between the people, but between the actual reality. So there's a cognitive coordination cost that is costly to us because we have to take the time to collectively figure that out and then wrangle the system back to health. The other reason that it's stressful is because we actually have lost the ability to predict those future states. If you think of that idea as a flashlight that we're shining around, it's like the light has gotten dimmer. We can't make projections into the future about the system is going to be working. We may not even be able to project, is this thing that I'm going to do to fix it, that delete table or delete from statement in SQL, is it going to fix it? Well, if I don't if I leave off a certain clause, it might make it worse, right? We probably had that if you've ever had to wrangle a data problem. So I want to do another quick survey here. Who here in their organizations do retrospectives after an incident? Good. All right. What is your main goal by conducting a retro? Shout them out. Learning. What else? Never repeat anything? Did I get that? Yeah. The mistake. Yeah, never repeat the mistake. What else? Why do you do retros? Visibility. That's a good one. Root cause. Determine the root cause. Yes. Any last ones? That's a good one. Yeah, this idea of blamelessness. Process? Yeah, improve process, right. So those are all good reasons to do a retro. But one of the most important and most beneficial impacts of a retrospective from a resilience and resilience engineering perspective is updating these mental models. It's updating what your system, the way that your system in reality has actually drifted. There's this concept of system drift, right? Updating those models so that the person knows what the reality of the actual situation is. And again, back to Dave's talk, every model is somewhat broken. It's not an exact model. It's my model in my head. The system has drifted from it. I may have an 80% sense of what that is, and it, without my knowledge, went down to 60%. And these are all fake numbers, but getting that back. But then the other important thing is finding out, with the operations engineers, the developer, oh, we're on Cassandra now, and we used to use some other data store, and it has these subtle differences. You should know that the next time we get called for a data problem. One of the things that I want to mention, there are now tools, right? There are a lot of kind of incident management or tools that like Jira that do incident tracking. There are starting to be tools that focus on this importance. Jelly is one of them, and you should check that out. But there are more people thinking about, this is the actual value that you derive. Those other things that you mentioned are super important, but this is actually the thing that engineers resilience in your system. Thing number 2, in our daily work, we are participants in a joint cognitive sociotechnical, you hear me use that word again, system. So what's interesting about this is, this might seem obvious, but there are points in time that we are more jointly coupled in our day-to-day work than others. And again, incidents might be one of these. I also worked for a startup, and I know it was a smaller startup, I think like 20 to 50 people, and whenever there was a board meeting, the CEO was very jointly coupled to what was going on because he had to go present the slides for the board meeting. He had to find out. So we were kind of talking him through that, and we were more jointly coupled, as it were. So this is some aspects of a joint cognitive system that are important if you want to engineer resilience into your organization. You need to have a really strong concept of common ground. So what do we mean by common ground? Well, there's a basic compact that's involved with common ground around this idea that we're actually engaged in the same activity and that we have the same goals. The important part about this is it's often tacit. It's not an explicit agreement that we make. But you can even see this in an incident response where somebody is trying to wrangle an incident and it's not even clear what the parties in the incident are, what their goal is. Sometimes that can be confusing because it is often so tacit. Goal alignment and commitment. And so this idea that, again, we are committed to the same goal in a particular context is part of common ground. Interpredictability. That's the idea. There's a couple types of interpredictability. There's interpredictability in that I work with my fellow database engineers, so I know generally what a database engineer would do, so I can infer what they're going to do. But there's also a team interpredictability. If there's a particular incident commander who always doesn't ask a particular question, then one of the interpredictability things is, Gary's not very good at that particular thing, so I'm going to help when he's commanding an incident to do this particular thing. That's all interpredictability. There's also this aspect of sustaining and repairing. This common ground that we have, a real core of it is noticing that we're actually, the thing that I expected you to do, the interpredictability that I thought we had in a high tempo, high consequence moment, didn't happen and then the cost to us repairing that, there's a cost there, but it's even more costly if we both fail to notice it. And finally, one of the big things that's actually the bullet point that isn't on the slide is this idea around sometimes people leave the joint compact and don't tell you. If you've ever had this in an incident, we've seen this where you're like, I haven't heard from Joe in 20 minutes, and Joe was like, oh, I was getting pizza. I looked at my thing, I thought we were done, right? And that's actually really important to this idea of common ground and improving resilience. So how do you engineer resilience from this aspect? All of these things make the team more resilient to dealing with all sorts of particular issues. Incidents are good ones, that's why we're talking about them, but there's other cases as well. Finally, emergent risk detection. So this is something that we started doing at Netflix. We called it Risk Radar. So a little bit of historical context on that. It was a repurposed meeting called, it used to be called Incident Risks and Learning. And one of the big changes that we made is that meeting consisted of a bunch of people. It was similar to if you've heard an Amazon Ops review. People would come with their incidents and they would present an incident. And when I went and talked to those folks, what we really found is it felt like a book report. It felt like they were kind of getting called to the principal's office. So we shifted the discussion from specific incidents to thematic risks. People coming and saying, you know, we haven't had an incident about this, but I'm really worried that this is going to blow up. We went from teams presenting stuff to teams discussing things. So nobody was on the hook. There wasn't a book report slide deck you had to present. And we went from this idea of what was backward looking to what was emergent. And the key point there is what had happened in terms of incidents and the retrospectives that teams had conducted. They came up with all sorts of different risks. But we didn't talk about the incident. We talked about the emergent properties of those risks that they had maybe not addressed because maybe they didn't have time or the agency to fix all of the problems that they found in a particular incident. One of my favorite quotes to describe this is a channel for sharing context that you wouldn't otherwise get or wouldn't otherwise get shared. It's kind of like eavesdropping near the water cooler about things that your engineers are actually worried about. So a couple of things that I'll mention. This radar represents a sort of probabilism. We're sort of talking about probabilities and engineers and managers' concerns in the system, which means some risks will never come to pass. But it's hugely valuable for leaders because it gives you a second order signal on what the people in your system are actually worried about. What are they anxious about? And you can get a read on that and then help address that. This is sort of where are the action items? One of the things, we often wouldn't come up with action items. Sometimes we would. But I can tell you one of the great uses, it was a great compliment at Netflix. There was a senior director there. We would put all of the risks into a memo that was consumable for all the engineers, but also for executives as well. And he said, I read that memo every month when you hold a risk radar because I want to know exactly what to be worried about in my part of the org and to talk to my peers about. There's a whole talk on this at jpaulreed/risk radar, so you can see more of the details there because I just grabbed a couple slides to talk about it here. All right, so what now? What are the takeaways about resilient engineering resilience at speed and scale in your organization? First of all, if you take nothing else away, resilience is a verb. It's something we actually actively participate in together. Resilience is our aggregate capacity to adapt to new and novel situations in real time. Why is this important? It's a capacity, which means it can be depleted. If you were seeing your engineers acting all wonky, maybe 4 to 5 months after COVID, it's because their personal resilience capacity was not being applied to work anymore. That was a component of it. There was lots of stuff going on, but that was a component of it. But this also means it's a skill. We can replenish it. It's a skill and a muscle that teams can build together. And if you've seen a well-running team that has dealt with a lot of incidents, you'll see that. They have that inner predictability. They have that common ground and understanding, and they're able to detect it when something feels off in the way that they're interacting. And you probably have seen that in some of the teams that you've run in. It's actually really beautiful to see. Incidents in particular are a great measure of an opportunity to improve your team's capacity to cultivate and summon resilience. And so this is sort of that idea that it's interesting to think about incidents as an option. right? Once an incident happens, you've already paid for the option. You've already paid the cost because you already had that incident. It's up to you to decide, do I want to leverage the money I already spent to learn from it and use some of these principles to engineer resilience into our organization in that way with the people? Or do I just want to let that option expire? So with that in mind, now go engineer some resilience in your own organizations. Thanks.